Hi, students and friends. Welcome to the channel Learn and Teach by Sir Ayaz. This video lesson is about redox. I've talked about redox reactions during February 2022. Last video was published on 8th February 2022. So here's a summary of the last lesson. The reactions in which both reduction and oxidation reactions are occurring are called redox reactions. Oxidation is either gain of oxygen or loss of hydrogen. Reduction is either gain of hydrogen or loss of oxygen. Oxidation can also be defined as loss of electron or electrons. Reduction Reduction can also be defined as gain of electron or electrons. Reductants are the reactant which reduces the other reactant and oxidizes itself. Oxidant oxidizes the other reactant and reduces itself. So the learning outcome for this last video lesson for the redox would be identify redox reactions by changes in oxidation number. This is something new which is inducted in 5070 syllabus 2023 till 25 version. It's common with the and in parallel to the syllabus 0620. So identify redox reactions by changes in oxidation number using the oxidation number of elements in their uncombined state is 0. The oxidation number of a monoatomic ion is the same as the charge on the ion. The sum of the oxidation numbers in a compound is 0. The sum of the oxidation numbers in an ion is equal to the charge on the ion. Define oxidation in terms of an increase in oxidation number. Define reduction in terms of a decrease in oxidation number. Before proceeding and talking anything about oxidation number or oxidation state, first you should know the concept behind the electronegativity. What is electronegativity? Electronegativity is the power to attract electrons. Is the tendency of an atom to attract electrons. Now, this tendency or power is owned by each element in the periodic table. Like you can include metals also in this. They all have some power or tendency to attract the electrons. There's a trend of electronegativity in the periodic table. So down the group, electronegativity decreases. Electronegativity decreases. But across a period, electronegativity increases. Which means that within the same period, elements having a higher electronegativity on the right hand side as compared to the elements on the left hand side. That's what I've talked about. I've talked about the decrease in electronegativity down the group. Decrease in En, electronegativity. I'm representing En for electronegativity. Negativity. And if you move from left to right, it increases. Like you will expect fluorine being most electronegative than oxygen. And in turn, oxygen more electronegative than nitrogen. And the same way, carbon more electronegative than boron, beryllium, lithium. And this is common on the period. Here's the values of electronegativity values for some elements. Like you can see, hydrogen has 2.1, lithium 1, beryllium 1.5, boron 2, sodium 0.9, magnesium 1.2, Al 1.5. You can see the trend. If you look at this, you can see down the group it's decreasing. Like you can see 2.1, 1.9, and along the period it's increasing. Consider the third period. sodium 0.9, magnesium 1.2, aluminum 1.5, silicon 1.8, phosphorus 2.1, sulfur 2.5, fluorine 3. Fluorine is the most electronegative element in the periodic table. Most electronegative. You don't need to learn these values at this stage. You just have to remember the trend. So what is the trend down the group? Decreases. Along the period, increases. And there are some rules when reducing or predicting the oxidation number or state of an element in a compound or in ion. You have to remember these rules. These rules are not that difficult. So for hydrogen, hydrogen is can be attached to any elements, like it can be attached to metals like sodium. It can form sodium hydride, and it can attach to non-metals, like forming a compound with water, H2O. So remember one point: whenever hydrogen is attached to metals, its oxidation number is always -1 here in this situation. But when it's attached to non-metals, it's always +1. So oxidation number of elements in their uncombined state. In their uncombined state, if they are not in any kind of involved in any kind of bonding, their oxidation number or state is always 0. It is always 0. So for these elements, you can see the elements, you can write 0. You can reduce by writing 0 on top of it. Means they don't have any oxidation number. At this stage, you will write or consider it as 0. Now, oxidation number of monoatomic ion, it is the same as the charge on the ion. So in case of sodium, it's +1. +1 is the oxidation number for sodium ion. Oxidation number, you can even call it oxidation state. Same way, magnesium +2, oxygen -2 or 2 minus, chlorine -1 or 1 minus. These are the oxidation state or number. Sum of the oxidation numbers in a compound, it's always equal to 0. So if we'll talk about the oxidation state of the whole compound, it should be equal to 0. Same case with other compounds, ammonia, sodium chloride, it's 0 for the whole compound, remember, not the individual elements. Now, sum of the oxidation numbers in an ion is equal to the charge on the ion. Now, here we are having polyatomic ions. These are polyatomic ions. You just see the charge on top. The charge carrying is -1. OH carrying -1. You can work out the oxidation number or state of both of these elements. As I told you, whenever hydrogen is attached to non-metal, it will always carry +1 charge. So I will write +1 for hydrogen. I don't know the charge on oxygen or oxidation number. The charge on the whole ion is -1. You solve in this way. So it will become X +1 -1 is equal to -1. What you will get? The value of X is -1, which means oxygen is carrying -2 here and hydrogen -1. In the same way, you can work out the charge on sulfur or oxygen atom in the sulfate ion. This is sulfate ion. S is on the left side as compared as S is below oxygen. They are in the same periodic table, and according to the trend, oxygen is more electronegative than sulfur. So oxygen is carrying -2 charge. SO4, oxygen is carrying -2. There are 4 atoms of oxygen, so you write 4 multiplied by -2. We don't know the charge on sulfur, so we'll write X +1. The whole charge is -2. In this way, you'll solve it. X -8 is equal to -2. X -8 plus 8 gives is equal to -2 plus 8. So cancel out these numbers. What you will get? You will get X is equal to plus 6. So charge on sulfur is plus 6. Here it's carrying plus 6 and oxygen is -2. Now let's explain the oxidation reduction in terms of change in oxidation number. So these are this is the example of reaction between magnesium and oxygen to produce the compound magnesium oxide. This is magnesium oxide. So I'm going to explain which one of these is oxidized and reduced. If you know the charge on magnesium and oxygen is 0, as I told you. What about the charge on magnesium and oxygen? In magnesium oxide, magnesium is a metal and oxygen is a non-metal. So we know the charge on oxygen. Oxygen is in the group 6. So can easily work out or deduce the charge on oxygen. The valency of oxygen will be the charge or oxidation number here. So you write here X -2 is equal to 0 because overall it's 0. Na? So X -2 plus 2 is equal to 0 plus 2. So what you will get? You will get X plus 2. So plus 2 is a charge on magnesium and -2 is a charge on oxygen. So which one is reduced and oxidized? Now we can make the statement here. I will make the statement for magnesium. Magnesium Mg is oxidized because oxidation number increases from 0 to plus 2. You can see here 0 to plus 2. What about oxygen? For oxygen, we'll make the statement oxygen is reduced because oxidation number is decreased. You see the number moving to negative side, so you write decreased from 0 to -2. So in this way, you will make the statement for redox reaction when you're talking about oxidation reduction in terms of change in oxidation number. So what's happening here? Let's write the charge on each atom here. Bromine is a non-metal, sodium is a metal. So you can easily work out the charges on these. So the valency of bromine will become its oxidation number. The valency of bromine is -1. So in order to balance this -1, sodium must carry +1. So +1 will be the charge on sodium. What about chlorine gas? It must carry 0. Bromine gas, bromine on the right hand side, it also carries 0 charge. What about the charges on NaCl? In case of Cl of NaCl, it must carry -1. For Na, we must write +1. It's a metal. So the oxidation number of Na is +1 and Cl is -1. So nothing is happening here in case of sodium. Nothing is happening. But bromide ion, this is Br. There's a charge on Br is minus here and here it's 0. So it's increasing. So it means it's reduced. So you write Br is reduced to Br2 because the oxidation number increases. Sorry, it's Br is oxidized. Br is oxidized. It's not reduced, it's oxidized because the oxidation number increases from -1 to 0. For chlorine, you write Cl2 is reduced to Cl because the oxidation number decreases. Oxidation number is decreased. Decreased from 0 to -1. That's all for today. Thanks for watching. Press like, give comments, and share my videos. For more videos, subscribe to my channel and press the bell icon.